Hey everybody, one more live stream today. So this is my second one today. Building the E3D ToolChanger printer here system. Once again, special thanks to E3D for letting me participate in the 30 program. Thanks to Phyllis Reuter and E3D. Yes, I'm going to say this every time, but these people help me out a ton. So big thanks to them, and thanks to everybody that tunes in for these or watches them later. Live questions are always appreciated, though. So in this live stream, I'm going to install the fun part, the ToolChanger head itself. So I did a couple previous videos. The first one was the unboxing video. Then I did the assembly of the motion system itself, the XYZ. The last one was a quick one. I did the 4 docks earlier today. And now I'm doing the ToolChanger head. So I showed this in the unboxing video. I showed it a little incorrectly, but this is the tool changing head. Hey, 3D print Viking. So this attaches on the x-axis. And then there's another part for the servo. As a prep for this video, actually a couple days ago, I added a flanged bearing to the ToolChanger head. You put a little bit of Loctite around it, you seat the bearing in there, and it's just held in with Loctite. So I did that prep on that. And there is another bearing in the servo plate, which goes on the other side. That's seated in the same way. Loctite, drop the bearing in. There you go. So I'll set these here for now. And I have my guide open. I need some Allen keys. I have my handy dandy set of Allen keys, tons of them everywhere, always. And we'll jump right into the install. So it says tools needed, 1.5 millimeter and a 0.9 millimeter Allen key, one of each. As I pointed out in the last video, everything comes in a box per component. Hey, John. So the ToolChanger coupler came in a box with all its components here. That's not from this box. I stole that from another box. So all the components for the ToolChanger head itself come in one box. Each set of components comes in its own nicely labeled bag. And then all of the little bits and hardware come in individual plastic bags. So it's all really nicely organized and easy to find. Hey, Matt, I'm not the most entertaining, but you might learn about the ToolChanger, which I know you want to get a hold of because this is the part that you're going to have to help me adapt to the Railcore. Hey, Leo. Okay, so like I said, step one is to put the bearing in the kinematic face, they call it, which is the Y-shaped component here that the tools attach to. Curing time for the Loctite is overnight. Check. It's been about 3 days. Servo plate, same thing, bearing into the pocket that I just described. So there's a bearing here. That's check. So step one, kinematic plate fitment. Apply thread lock to 4 M3 5mm button head screws. So I have my thread lock out from the last live stream. I'm just going to dump all the stuff on a paper towel here so I can easily find it. 1, 2, 3, 4 5mm button head screws. Drop a Loctite each. make a giant mess. Okay. Sorry, just reading the instructions here. So the instructions say to fold up the belts, which was confusing me because the belts on this side of the tool changer, I don't know if you can see it real clear, they're very short. The tail end of the belt is short, where on the other side here you can see this is a much longer tail on these two. So what it must be referring to is if this side, you know, facing the tools is longer, you want to clip that short. So since I don't have to worry about that, I can just push this on here. Get my 5mm button head with Loctite on. I actually did read the manual this time while I skimmed it before the live stream. I haven't been doing that, and Greg's been giving me grief about it. So I did skim it before I started. So 4 5mm M3 bolts. Yeah, Greg said he was going to try and join this one. We'll see. He likes to tell me to read the fine manual. That's what the F stands for in that, right? RTFM, read the fine manual. Okay, so there's the 4 M5 button head bolts. Step 5, servo gear. Remove the plastic arm from the servo. Okay, let me find the servo here. So, talked about this in the unboxing video, but this is, see if you can see it here. I don't know if that's backward. It's backward on my screen. Maybe you can read it. It is an HS70MG high torque feather servo. It's a Metal Gear hobby servo, like you'd find in an RC car. Pretty nice little servo. So set the parts for that aside for now, and it says to remove that screw. So let me find a small Phillips screwdriver here. Remove the plastic arm, saving the bolt and washer. Bolt and washer saved. Plastic arm removed. Insert the M2 3mm grub screw into the 20-tooth servo. Oh, into the 20-tooth servo gear. That makes more sense. I should read. Okay, so what it's talking about there is in this bag. It's a good question, Mark. So the plan is to use certainly this plate that I just attached, this Y-shaped plate. At the very least, we will probably also need to utilize, if not this exact rear plate, a close copy of it. And the spacing will be very interesting. So that's going to be a challenge with how the rail core Y-axis is currently configured. To be honest, I have not started figuring that out yet. I want to get it working on here, see what works, what I like, what I don't like, before I try and move it to the rail core. So that's why I'm building this, is to get a feel for how these parts fit together, why E3D did what they did. If it makes sense to move it as is and adapt the rail core to this, then we'll do that. If it makes more sense to have Matt, who's on mill alternative plates and adjust things, we'll go that route. So I do not know how much space it's going to cost. That is, you know, I haven't gotten far enough to figure out how we're going to fit this yet to guess remotely how much space we're going to lose. I mean, there's no question you're going to have to give up some volume in order to fit this on your rail core. It's just a question of how much. But that's, you know, that's part of why I wanted to get into this beta, is so I could get a feel for how these components fit together and figure out how E3D did things, so that when we adapt them to our printer, we're taking the parts that make sense and work well with our printer. Okay, am I missing something here? I'm talking while I'm working, and I need to find the grub screw for this servo gear. Is it in this bag? I'll bet you it's in this bag, because this bag looks like all the standoffs and pieces for the servo itself. So I'm just going to dump that out there, and sure enough, there's a tiny grub screw. That is extremely small. Do I have... I hope I have an Allen key that small. That is tiny. I'm not sure I do. Yeah. I have a lot of very small Allen wrenches, but that is on another level. Put the bigger ones back in. There went one. I do not see an Allen key that looks small enough in this stack. I have a couple others. That is the smallest grub screw I've ever seen. So let's see what's on here. The smallest on here is a 1.5. There's the Loctite super glue I was looking for earlier. Huh. This could be a real challenge here. What do I have on this? This is what I was looking for. Yeah, so if you're building this, yeah, even this grub or this Allen key I have, which is super fine, is twice as big as what I need. Huh. That is way tiny. I'm not sure how far I can make it without that. I'm just looking through my assortment here of different tools to see if I have something, but I don't think I do. Possibly in here. Anybody know any alternatives for Allen wrenches if you don't have one quite small enough? Clever tricks. This might do it. Okay, I may have just come up with the dumbest trick ever, but it seems to work. Okay, so what I'm using is a standoff from a header for Arduinos and that kind of thing, just a little copper header. That is not tight, but it's on there. So this grub screw uses a, still not getting it tight with that. This is a 0.9 millimeter according to the guide. But like I said, it's way smaller than any Allen wrench I seem to have, or Allen key I seem to have. I have a pretty good collection of them, like everybody in 3D printing does. I think any of these are going to be anywhere near small enough to turn this. I'm not able to get that tight. I'm sure this is entertaining. Let's see here. Where would I have Allen keys? Nope. Nope. Well, I got it somewhat in there, but it is not tight, and that's not going to do for something as important as this. Yeah, I don't think I can print a 0.9 Allen key that's accurate enough. So suggestion to E3D would be to include one of those, because those are not a common hobby size Allen key. I really thought I likely had some other stashes of them, but I'm not finding any. Double check in here. This is the fun of doing this as a live stream, is sometimes things go horribly wrong. Thought this was going to be an easy one. Another Allen key, too big. Yeah, I'm not sure I could file one down accurately enough to fit. Nothing near that small in there. Hmm. Nothing in there for sure. Nope. Nope. Well, because where I'm at right now, you know, it might, if I could find one. I hate to walk away from a live stream. That is quite unexpected. Let me go. I'm going to step away for just a second. Entertain yourselves, and I'll be right back. I'm going to check one more spot for one of these. Well, no Allen keys, but I got a couple of screwdrivers I can try. Okay, that got it tightened down enough. It's holding at the moment. I'm going to double check. I have a couple E3D parts in here. Maybe it's in one of these bags. Or maybe one small enough to fit one of these. Nope, I'm not seeing anything. All right, well, we'll hope that's good enough for now. And before the actual live stream, I'll find some way to tighten getting everything moving. I'll figure out a way to tighten that down. So, word of warning, that is a crazy small. Yeah, I have a couple Torx here, but nothing small enough to get that. That's actually what I ended up using as a little Torx head. And it still doesn't really fit in there. Huh. Of course, Greg will probably come on and be like, yeah, we included one. It's in the bag, blah, blah, blah. I don't know. I don't see one. Okay, so I'm going to move on. It's on tight enough that I can't pull it off. It seems to be gripping fine. And then it's held in place by the screw and washer from earlier. So I need to drop those back in. So that, it has two components holding it down. So there's that. Tighten that. Okay, that seems pretty darn tight. So call that good. Let's see, our next step. Pass the cable through the servo plate as shown. And position the servo as shown. So the gear, I'll show you here, the gear for the servo is closest to the center of the plate, facing away from the side with the bearing in it. Thread lock on some M2 bolts to hold the servo in place. Seem like awfully long bolts for holding the servo in. So it's just one bolt on each end of the servo to hold it onto the plate here. Once again, my Allen keys are not fitting this. These are M2. I need that There we go. Okay, so I got the servo attached. Put that there at the moment, and fit the end stop to the servo plate using an M3 8mm grub screw. So this is a clever thing that E3D did. Or I said grub screw, it's just a regular screw. E3D is using an end stop for Z-axis homing. So doing your homing to the bed. And why I say it's clever is this end stop can only hit the bed when there's no tool installed. So as long as you haven't picked up a tool yet, you can home your bed. And then once you've picked up a tool, this will no longer be the lowest thing on the carriage and isn't in the way of anything. So kind of a clever little trick on E3D's part there to use just a standard end stop switch. Show you here off of the bottom of the plate for Z-axis homing, and nice and out of the way when when you have a tool picked up, it's not the lowest thing there. Okay. So for this, instead of bolts, we use four 6mm hex head standoffs to install it. Drop a thread lock on each. Okay, so here I have to fold up the belts. So this is, I know you probably can't see this too well. Yeah, Dottis, we have a couple different methods we've discussed about doing the tool offsets automatically. Steve and I actually have something we've worked out together that he has working on his rail core now that does tool length offsets automatically. The one thing it doesn't do is the XY position of the tools, but as long as the tool center remains the same when you pick it up, we can already do the tool length offsets, and it's using a micro switch. So we have that tested and working already. So what they want me to do is, here we go, fold the belts up so that they're inside of this when it's on and not overlapping the edges, which means I need to cut these belts a little bit. They're a little bit too long. So just taking a couple teeth off. This is nice. It's that 2GT belt that E3D started selling recently. It's all genuine gates. Nice belt. So I fold those over, and then I push the plate. Why does it feel like I'm hitting something? Because I'm hitting something. How about that? There we go. So there's a ridge in the back. I'll show this here. There's a ridge on the back plate of the servo mount. If that pinches the belt, when you're installing it, you won't be able to get it flush. So you've got to make sure the belts are horizontal when you fold them over each other, and don't cross the plane of that point. And then we use the standoffs through the plate to attach the plate. So these are, I'll show you here. Hopefully you can see that. It's a standoff instead of a bolt. So you can put another bolt in the end of it, like a PC standoff. Yeah, I was talking to Sanjay yesterday about some ideas for doing XY. I would think doing a Z home like what we have planned, just touching off a micro switch and getting your tool length offset. Once you've homed Z, if you picture your nozzle, you gotta have a nozzle here somewhere. Got like 7 hot ends right there. Okay, so if you picture your nozzle has that nice cone shape to it. So if you've cleaned it and homed Z, now you can lower it into a circular opening, similar to right here. There's a circular opening. Lower it in 1 millimeter, and then you can tap the sides in a square. And by tapping those sides, you'll find the center. It's a common CNC centering method for finding the center of a tool. So as long as your nozzle is round, regardless of shape, and you've already homed Z, you can find the center of a nozzle that way. So that was my thought on how to do that. And it's a known, the G code's already there because it comes from the CNC world. Okay, so I got those installed. Fit the 4 standoffs. I just hand tighten those for now. Okay, so this is the interesting one. So the way E3D picks up the tools, I'm sure you guys have seen this, is they have a steel shaft that the servo is turning. And so that's this piece here. It's going to be really hard to get the detail in the video, but there's a groove here that I need to fit a clip onto. So I'll do that. Press that against something. So it's just a C clip that fits into that groove. There. There is a hole through there that a bar goes across. The end of the pin, the shaft here, is actually threaded, and so you can slide the bar in and then run a grub screw straight down the end of it to press against the bar that goes across. The other end of the shaft is also hollow and threaded, so it can thread onto this assembly here. So it's kind of an interesting part. And the implication for the rail core is I had wondered how complex this would be to recreate, because with how complex it is, I think we're going to have to use this, which means our spacing for our 2 ToolChanger plates is going to have to mirror the spacing of the ToolChanger plates from E3D. So that's an interesting consideration. Really complex little part here. So what I'm supposed to do is take the bar and pass it through in that slot I was showing you, and then use an M3 grub screw. Nope, that's M4. Need to put some thread lock on it, of course. Like I said, I have no idea how clear that was in the video, but it's really a clever item. But with how machined it is, it's going to be hard to replicate. And it dictates the spacing. So here's where I was saying the end of this is threaded. I have a grub screw in there, and then I need to center that bar best I can. And there we go. So torque that down just a little bit more. Yeah, so our plan is to use a micro switch for the rail core. And like I said, Steve and I have that worked out. He's been testing it lately, and it's been working well for him. So I slide this into the bearing and the kinematic plate. So now I have the shaft slid here into the bearing. It says do not push it all the way in because we have to add a thrust bearing to it. So open the package with the thrust bearing. And again, I know my camera isn't the greatest of quality, but here is the thrust bearing. Comes in 3 parts. And they want me to note one of the 2 races has a larger inner diameter than the other. Make note of which it is. Try not to lose any of those parts. One of them has a larger inner diameter. So if I hold these back to back, they look identical. Okay, when they say larger, they mean just fractionally larger. So holding them back to back, and again, I know my camera is not going to pick this up. Those 2 sides sure look identical. But this one is slightly larger. Just fractionally. My eyesight were any worse, I wouldn't be able to see that. Okay. Place the thrust bearing race with the larger internal diameter onto the shaft. Okay. Trying to see where onto the shaft this goes. Goes there. Make sure the groove to the race is facing outward. Check. Place the bearing cage onto the shaft. Check. Place the remaining race onto the shaft. Grooves facing inward. Check. Okay, there's a spring. There is an M3 washer, set screw, M4 washer, 8mm. So they have me putting an M3 washer, an M4 washer, drop a thread lock, take the spring, put it on the end of the shaft here. That's going to be fun. This is the first point at which I've thought, you know, a second person would help. Oh, that's a good trick. Okay, if you spin the shaft from the other end, it works better than trying to spin the Allen wrench. Okay, fully tighten the screw, compressing the spring down. I skipped a step. How did I skip a step? I totally skipped the 40-tooth gear step. So I got to take this apart. I was going to say, there's nothing holding it together. See, if Greg were here, he would be shaking his head. I skipped a step talking to people. Let's make sure none of this flies apart when I loosen this. So I gotta slide this back out of the thrust bearing. There's a 40-tooth gear that I did not put on. I get something wrong every live stream just to make it more interesting. Gonna put a drop of thread lock onto these two. So this is a just a standard 40-tooth metal gear. Gets two grub screws, one coming in from each direction. You just partially thread them in. And the bearing, or the shaft faces away from probably don't want thread lock on those, because it says the positioning of this gear will be done when you power on the machine. So clean that off a little bit. Once again, if Greg were watching live, he would be making fun of me. Clean that up some. Okay. So I need to slide this up inside of here and twist it around. I'm not good at this. There we go. Nope. There went the thrust bearing. I knew it'd fall out eventually. What have I done? There we go. Just trying to get the shaft to slide into this 40 tooth. I've almost definitely done something wrong with the instructions here, because this is not. Not wanting to slide in there. You guys still there? I haven't seen any comments. Maybe YouTube's not showing me the latest. I don't have either of those in too tight. Well, maybe that would be the case. Back them out slightly just in case. And put this back in. All right, you guys are still there. That's good. Fitting this gear is not for someone with hands as big as mine. There we go. So the back half of the thrust bearing is still in place. Come on. Now that I have that gear on, I'm getting just a slight bit of binding when I try and push the shaft through as the gear tilts. There we go. So now I can put the thrust bearing back together how it was. We're back in business. Put the spring back on. Still have my M3 bolt with its thread lock. I'll probably regret putting thread lock on that when I go to adjust it later, but it is what it is now. That's something Greg can give me a hard time about tomorrow. He's great for that. So this is the M3 bolt with the M3 washer, M4 washer, and spring. It didn't seat quite right. Yeah, I need to put another drop of thread lock on that bolt. There we go. Okay. Come on. There we go. So that's threading on fine now. So now the servo can turn that metal gear once it's locked in place, which can turn the tool pickup arm and pick up the hot ends. Okay, so that's the Y-axis install. I'm gonna pull the camera over here and give you guys some close-ups of it. So here's the Y plate. You can see here's the pin through, has a grub screw here, through a bearing in the plate, has a locking C-clip here, 4 M3 bolts holding that plate on. Cord got tangled. Here's the rear plate. So here's the spring M3. This is the servo. Down here you can see is the micro switch for homing. And then the view from underneath, hopefully you can see here, I can show you. Here is the 40 tooth, and this is the brass one attached to the servo. I do have access to that brass one, so if I can find a smaller Allen key, I can torque that down a little bit. That should help. Although having that bolt in the end of it really holds it in nice. So there's the side view of the entire assembly. And this will end up somewhere like that. So that is the ToolChanger portion of the E3D ToolChanger. The next video will be installing, building and installing the V6s that'll mount here. So there will be 4 of those to, there's a holder that you build. They're the threaded heat sink. Let me grab one here. So for the next video, it'll be, there's a wiring bundle, pretty standard for V6. They're the threaded heat sinks that you've all seen before. But there's also some aluminum mounting parts for the docking station for them. There's a nice plastic part for that. They do include layer fans. Of course, that's a duplicate of that from a different one. pick some boxes up. And then this is the plate. I'll show you this here before I end this stream. So this is the plate for picking up the tools. And so this, turn it the right way, is what gets picked up here. And this spins. Can't do it by hand. And picks up that plate, and this plate is attached to the hot end itself with these 6 bolt holes. So that's what I'll be doing in the next one. There's also a handful of printed parts for each of them. Grab those here. So there's a couple of printed parts I did for those. And I have some layer fans actually sitting on my printer still. So that'll be the next live stream. I might be able to do that live stream tomorrow. That's what I'm hoping. So I'll target that, and if I can't make that work, I'll update on the Railcore Facebook and on my Twitter account, which is at Kraegar, Kraegar. Those are the best ways to watch and see when I'll live stream, or of course subscribe to my YouTube channel and it'll pop up on there. But yeah, that'll be the next one, is installing those 4. And then the final live stream will be the wiring, and then I'll probably, I don't know if I'll do a smoke test right then, or if I'll do that as a separate live stream. I'm trying to do one per each build guide that E3D has. So I think that's it for this one, unless anybody has any questions before I call it. Give you guys a second to think of any last minute questions before I call this live stream. All right, thanks everybody. Looks like nobody has any questions, so I'm going to call that. Thanks again to E3D, to Phyllis Reuter, to Duet, Snow Labs for the CF PC Plus for the printed parts. It's been fun. Thanks everybody for watching, and I'll get another live stream up probably tomorrow, the 2nd, to take a shot at the next one.